Let us now study about quality factor or Q factor. Okay, so let's take an LCR circuit. Okay, so in an LCR circuit we study that it's like this way. There's a coil there, then we have a capacitor, then we have a resistor. Okay. Then we connect to an alternating supply like this way. Okay, this is alternating supply. Okay, AC voltage. This is the inductance, capacitance, and resistance here. Okay, LCR. Okay, inductance, capacitance, and resistance. They connect in series. Okay. Now we say define quality factor as voltage across the inductor or capacitor at resistance divided by the applied voltage. Okay. So we apply some voltage and we want to see this is applied voltage here. Okay. And we want to see what is the voltage across the inductor or what's the voltage across the capacitor. Okay. That ratio we call it as quality factor. Okay. So let us see now the formula for quality factor. It's Q factor. Okay. That's equal to the voltage across the inductor data is L, okay, or capacitor C, okay, at resonance. Okay, what's meant by resonance? The input frequency is equal to the natural frequency of the object, okay, of the circuit in this case here, divided by the applied voltage. Applied voltage. Okay. So let us now see voltage across the inductor or capacitor at resonance. Okay, so voltage, now I'll take only the inductor. Let's imagine that we take only the inductor. We want to see what's the voltage across the inductor, that is VL, that we want to find. Okay, so voltage across the inductor that we learnt already, that is VL. Okay, VL is equal to, we use the Ohm's law formula, and then IM into this XL. Okay, so IM means what? The maximum value of the current, and XL is the inductive reactance. Okay, and applied voltage, the voltage that we are giving. Okay, so that applied voltage, that is, we can write as VR. Okay, that's equal to voltage across resistor. That means why we say this is, okay, is because, see, suppose we give a voltage here. Okay, at resonance, what happens? The inductive reactance is equal to capacitive reactance. Okay, they'll cancel each other. Okay, so the circuit will have only resistance only. So we can write as the applied voltage is equal to the VR, the voltage across the resistor. Voltage across resistor we can write as using Ohm's law, that is the maximum value of the current into the resistance. V is equal to IR. Okay, this formula we're going to use here. Okay, so remember that. So now we're going to substitute here. Okay, so voltage across the inductor or capacitor at resonance. Okay, that is VL by the applied voltage is VR. Okay, VL by VR. So VL is how much? That is, we got here, that is IM into XL divided by IM into R. Okay, so just substitute values here. So IM and IM will cancel, so we get here XL by R. Okay, let me erase the board here and I'll write this side now. Okay, so let us continue here. So last step I got was, that is XL by R, the inductive reactance by the resistance. Okay, now XL means what? The inductive reactance, that is here XL, that's equal to, we learned that that's equal to omega into L. Okay, this is already we derived. Okay, and here omega means what? The angular frequency. Now in this case is resonance, so I write as omega R into L. Okay, so this is omega R. Okay, now let us substitute the values here. Okay, so that will be equal to omega R into L divided by R. Okay, so let's see now. Now omega R, that means the angular frequency. Okay, at resonance we learned that omega R is equal to 1 divided by root of LC. Okay, so you see the condition here, just reference in the book. Okay, so there's 1 or 2 pages before. At the resonance, the angular frequency is equal to this value here. Okay, so this value we're going to substitute now. So 1 by root LC. So we write as L into, okay, and then R will come down. Okay, instead of omega R only, we're writing here 1 by LC, root LC. So 1 by root LC. Okay, so we can understand this. You multiply this L by R into this term here. Okay, now you see this L. Okay, we can write as root L into root L. Okay, so L is equal to root L into root L. Okay, this way you can substitute here. So instead of writing L, we can write as root L into root L divided by R here, and then root LC is there now. We can split and write here. That is root L into root C. Okay, now root L and 1 root L will cancel. So what you get? You get here root L by root C. Okay, now let me erase the board here and then we'll continue. Okay, Okay, let us continue now. So last term that we got was, that is, we got here root L divided by R into root of C. See, this root L and root C, this is common here. Root is common, so we can take common root here. Okay, so what happens is we get here 1 by R, okay, into root L by root C. Okay, so we connect the root commonly. Okay, so this will be equal to the quality factor. Okay, Q factor here. So quality factor, that is equal to 1 divided by R into root of LC. Okay. So this is the value of the quality factor. So we know this now. Okay, but actually what's the physical meaning? Okay, so for that what we do, we take the LC circuit again, inductor, capacitor and then a resistor. Okay, R here. And this is applied voltage, V. Okay, V is applied voltage, inductor, capacitor and resistor, Z. We can write it anyway also, same only. Okay. Now at resonance, what happens here? Okay, this XL is XC, we know. Okay, but what is the physical meaning of the quality factor? Okay, this is Q factor. This is 1 by R. Okay, R means resistance, into L means inductance, and C is a capacitance. See, suppose for example we are giving here 1 volt. Okay, and then suppose we have quality factor of 10. Okay, imagine we have a quality factor of 10. This is a quality factor we have. Okay, that means across the capacitor, if you see, the voltage will be 10 volts here. Okay, imagine we are giving 1 volt only, but at resonance the voltage across the capacitor will be 10 volts. Okay, the voltage across the inductor also will be 10 volts, but you can get here minus 10. Okay, so plus 10 and minus 10. Okay, so they will cancel each other. Okay, so what happens is we give a, it's called volt, it's like voltage amplification. Okay, we give only 1 volt here, but out of across the capacitor we get here 10 volts. Okay, so voltage is amplified. Okay, suppose you have quality factor of 100, means 100. What happens? The voltage of the capacitor also will be 100 times larger. Okay, this is about the quality factor. Thank you for watching.